We've been using almost 200 megawatts for the last 3 years there. We'll see how this year pans out there, but we get a report at the end of the year that it saved the utilities customers because they share the revenue back with the customers. So the customers on MDU saved $5.3 million the first year we were there. Massive, probably the biggest supercomputer in the world, because you have 100 megawatts of critical IT load, all interconnected with InfiniBand. But the reason we did the 3 stories, you run network core through the middle, then you can interconnect all of that on kind of that 30-meter distance limitation on InfiniBand. And so for me to be able to take the cutting edge of technology back to an area that's just like I grew up in is rewarding. But also the big positive as well is it's a huge positive impact on the community in which we locate our data center.
Wes, thank you for joining the Baxtel Podcast.
Thanks for having me, Eric. I appreciate it.
Great. So before we dig in, I want to learn about you in 60 seconds. I'll ask you a series of quick questions, and please answer the first thing that comes to mind. So do you prefer late nights or early mornings?
Early mornings.
Sweet or salty?
Salty.
Introvert or extrovert?
Extrovert.
Favorite food?
Cheeseburger.
Favorite sport?
Football.
What was your first job, early on outside the industry?
So at first I worked on my parents' farm, the family farm, as I grew up. And then my first job off the farm was I was a auto mechanic in college.
That's impressive. I didn't expect that. And I've never considered being a mechanic, but good for you from that perspective. I like
that. Skills learned on the farm.
True. I guess you repair your own farm equipment then.
Yep.
Let's see. So fiction or nonfiction?
Nonfiction.
Secret talent?
Superpower, I call it, is that I don't have an allergic reaction to mosquitoes, so they bite me, but I don't swell up. It's really, really great.
That is a superpower. I'd say you're if I don't know how many mosquitoes are down in Texas, but if you're up in lots.
A lot.
Okay, good. And then probably in North Dakota, there's probably plenty up there.
Yeah, in the summertime, and they're big.
Okay, so getting into some work questions. Do you prefer email or a meeting?
Email.
And then cabinet or rack?
Rack.
And then grid or behind the meter power?
Grid. Very strongly grid.
Batteries or gas gen?
Can I say both?
Sure. You can say what you want. Who would play you in the Netflix series Data Center Wars? So some actor.
I think McConaughey.
Okay. All right. Now that we got to know you a little bit with these series of fun questions, let's get into it. Applied Digital is building a massive campus or a series of massive campuses in a very rural part of North Dakota. Why do you choose Ellendale, or maybe the other? Ellendale is first, but why are you choosing very remote spots?
Yeah, so I would say this: it's a mix of we choose, but the site kind of chooses us too. And I say that by the way we found these sites is where is the power available, and then you need a few more boxes to check, which is it's primarily power, the type of power you get, and then fiber. What's the fiber access look like? So it's not unlike data center capacity that that is traditionally been planned, years and years and years ago, where if you wanted more capacity in the Dallas market or in the Phoenix market, you pulled up the tool that told you where real estate was available with fiber, and you landed there, and then you requested power from the utility. So it's similar, but we're looking for large scale power, and so it takes you to different sites where you have the grid infrastructure, the power gen, and the fiber that all comes together. And these happen to be the locations where this all comes together.
I see. Yeah. So I imagine it's part of like long haul fiber routes, in Ellendale. And I haven't looked at it before starting the podcast here, but I imagine it's long haul fiber routes. Probably going down. What's that?
A lot of cross country routes that go through North Dakota. It's a great state to do business in. And I think it's probably a great state to lay a lot of fiber through. And a lot of the routes if you want to run Seattle to New York, probably goes through North Dakota. And And so we actually, in Ellendale, North Dakota, which is 1,100 people, we have 4 different fiber providers and 4 diverse routes, both lit service and dark fiber. So it's a really robust fiber, not just there, but through the state.
Do you know the approximate latency down to Chicago? Because I imagine Chicago is the closest interconnect hub.
Yeah, so Chicago's like 15 round trip milliseconds, but the ones we've really tested to, actually Chicago's kind of one of them, but like Des Moines, which is a big Microsoft data center place, is one, and you get it's right around 7 or 8 milliseconds latency round trip. And then Cheyenne, which is a pretty big market for some of the hyperscalers, Denver, Minneapolis, and Omaha, which is big Google data center area. And we have really good latency to all of those. Our Ellendale campus was qualified by three different hyperscalers as big dual use, mixed use, inference, and training. So it hits the kind of the latency targets that they need to go to their nearest peering point, or 2 peering. You usually actually have to do 2 peering points.
Although it sounds like, having interconnection to their campuses, say if it's a Microsoft, any hyperscale, like having a connection and low latency to some of their existing campuses, in addition to internet interconnect points.
Yes.
That's
yeah. But just, I'll tell you, Eric, just from the due diligence we've been through, the onboarding processes we've been through, they focus much more on their own peering points, because we've had to do it for different hyperscalers to different locations. They focus on their own much more than internet connections.
Okay. Interesting. Which would be their own campuses, I suppose.
Yeah.
Okay. And that'd be great, particularly because there's more and more hyperscale campuses in rural locations.
Well, you've seen the trend even before AI. The trend was moving towards the middle of the country, towards power, right? I don't really consider Omaha a population center for the United States. I don't consider Des Moines a population center, Cheyenne a population center. So you've already seen that moving in. So like, North Dakota is a pretty easy extension of that, and we're really creating that market.
Mm-hmm. Makes sense to me. What is the most surprising thing about like this rural location? Both positive and negative.
So the negative is just, it takes a little bit more to get the labor force there, and a little bit more of our own infrastructure for labor on site, as you could imagine. The real positive is, just in my background, I've mentioned that I grew up working on the family farm. I grew up in a town of 200 people. And this was, I graduated high school in 1995, and kind of as we were going through, the internet was just starting. And I make a joke, but it's funny because it's true. I think my parents stopped using dial-up internet in like 2018. And it just was an area that was left behind. And so for me to be able to take the cutting edge of technology back to an area that's just like I grew up in is rewarding. But also the big positive as well is it's a huge positive impact on the community in which we locate our data centers. So think of these small communities, like I said, 1,100 people in Ellendale. We work, like, we're very integrated into the community, and we work closely with them to make sure we have a positive impact. There are negatives that come with it, just in the extra traffic that goes through for the construction phase. But once these are running, you have a few hundred people that go in and out every day. It creates really high paying jobs, but it doesn't create so many that you completely change the face of the community and the reason that the residents want to live there in the first place. But you create some jobs. So a lot of people who grew up, we've had, I think, 10 people so far that grew up in or around Ellendale, North Dakota, left because there wasn't really any job or career for them there, now have come back because there's a high paying job that they can work. So that's great. And then obviously the tax revenue that become almost, not overnight, but over the time span of a couple of years, maybe the wealthiest school district in the state, all of the thing that people don't think about in these small communities is, so you have a town of 1,100 people, they're still doing a water system, a sewage system, they have roads. And the only way for them to pay for these, usually if they have any extraordinary expenses, is extra tax levy on all their residents. And now that kind of goes away, so they can pay for their infrastructure. That's the first conversation we have. Like typically when you go to the mayor, the city council, and the only thing they think of is, man, we're going to be able to fix the water system or fix the sewer system or fix this road or that road. And it's all infrastructure. So it's a really big benefit to these communities. And so it's very rewarding for me because of where I came from. Even if I didn't come from there, I think it would still be very rewarding, but that's definitely the biggest positive.
I want to get into the community part later, but we scratch at it a little bit now. It's almost like these like Ellendale will have the best football stadium, high school football stadium around, right? Because there's a data center there, and I think that's what you're getting to in terms. So there's obviously sales tax, from a tax perspective, because I think that there's a lot of misunderstanding and FUD out there around data centers that are being built and proposed, right? There's in many different communities, it's surprising me. And we are actually starting to track this on Baxtel, community sentiment and how communities or which data centers are being canceled because, communities are pushing back. And it almost seems like it's maybe I should make a judgment on it's whose best interest, but it feels like there's a lot of misunderstanding of what data centers are. And so, I mean, even from a tax perspective, and you touched on it earlier, there's sales tax, but what other types of, what type of other taxes or revenue pieces to the community can data centers bring?
The property tax is the number one, right? I mean, this is going to the community, to the school district. It's state by state or town by town how it works, but the property tax is number one. And so, with the size of campuses that we're building, the community directly benefits by millions or tens of millions of dollars per year from a tax revenue perspective. And then sales tax to what's applicable depending on the state, right? That's more of a state revenue generator versus a local revenue generator. But I love the fact that it's mostly property tax that goes directly where we're building, directly for that town, directly for that county. And so it's a really big benefit there. And then the other benefits are just, the ancillary benefits, the ancillary economic benefits. Like while we're doing construction, there's a lot of, economic activity that wouldn't exist in those locations that does exist. And because it's in a small area and how we do, deal with the labor force there, the surrounding communities get a big benefit as well.
Right. And what, the biggest concerns from communities, maybe I'm missing some, and correct me if I'm wrong, but it's maybe lack of jobs that are created, water, that the data center is going to suck up all our water, that they're going to, if the data center is built here, our electrical rates will increase. Mm-hmm. From an electrical rate perspective, all these things are solvable I think by the industry with different technologies, right? But from an electrical price perspective, I think there's been studies that have shown that states with the most data centers or most data center growth have increased the least. North Dakota, I think, was one of those states.
Yep. Yeah, so that study just came out. Was it Berkeley? It was an educational institution. I was actually just reading it yesterday. I wish I remembered exactly who it was. But that study just came out, and this is true. And I'll give an example of specific to our Ellendale campus. We've been using almost 200 megawatts for the last 3 years there. We'll see how this year pans out there, but we get a report at the end of the year, and it saved the utilities customers because they share the revenue back with the customers. So the customers on MDU saved $5.3 million the first year we were there, and they saved $5.8 million the second year we were there. And why is that? It's because where we locate specifically, there's excess power. And then we utilize existing infrastructure and then we pay our tariff, right? We pay our transmission fee to the utility, which is, revenue and profit to the utility. And then they get to keep some, but then they share a lot of that back because this works almost the same everywhere, but it's a regulated utility and they get a certain return on their assets. And so if we utilize those assets more efficiently or higher utilization, then they get more revenue off those assets, but they're capped at what they can make from a rate of return. That's just generally how utilities work. So then they share that back with their constituents inside the utility. And so data centers at large, because we use so much power at this single location, it takes a lot less infrastructure to service that power. And like if you just went to North Dakota and you said, okay, well, this data center uses the same power as 60,000 homes. Understood, fine. That's a big number. But then when you think about the electrical infrastructure build to service 60,000 homes spread out in a rural area, by the way, versus one single site, like you just see how that pans out from actually lowering rates for everyone versus increasing rates. And the study you're referencing did show that the data centers pay more than their fair share on the utility side. And it's because of this. It's because you're utilizing so much at a single location and you don't have to build, and the utility doesn't get to spend, because utilities want to spend money, right? They're a yield-based model. So the more CapEx they can do, the more return that they can get. But again, a location like ours, there's only so much CapEx to do. We actually located right next to an existing substation. We pull from that substation. We have a new redundant substation on site that we paid for. So that doesn't go into the pool. But yeah, we've seen an absolutely clear direct benefits.
Right. No, that's a good point. It's a perfect number for it. It actually might be a lot of people need to retrain as data center technicians in those communities. Yeah. Let's see. How do you come up with the name? You're changing the topic a little bit. How did you come up with the name Polaris Forge?
Polaris. So I've done this education. So Polaris is the North Star, and then the forge is where things are made. And so we did a lot of tinkering around with that, but that's the reason for the name. It's North Dakota, and we're far north. It's about as far north as you can be in the United States, and it's where big data is made and where large language models are forged. And so I thought it was a good name. It's got a good meaning.
Yeah, I think it's great. There's too many times in the real estate, because data centers are like a real estate business, and
Yep.
there's too many times where the name of the building is the name of the address, which is fine. I mean, it's indicative, but it's not interesting.
Yeah, it's not. And inside the company, you say this name over and over and over again. And so one of the typical is the address or the nearest airport, right? And so then it's just the three letters of the nearest airport. So we could have ABR, which is Aberdeen, South Dakota, and then FAR, which the nearest airport would be Fargo to our others. But that you say these all the time inside the company, and so it's a name you deal with constantly. So I wanted something that's a little more exciting for everyone, and sounds exciting when you say it because you use it every single day, many times.
Yeah. Although you probably shorten it to PF.
Yeah, it's PF1, PF2. Yep, you are correct.
Cool. All right. So let's understand how, I think you guys have some insight in terms of how AI data centers are different. A couple of years ago, you guys made a pivot. You made a pivot, of course, out of crypto and into, HPC. But even beyond that, once you moved into HPC, as I understood it, right? And correct me if I'm wrong, you stopped the design process and redesigned it, at least your first building there. And would love to hear background around that decision. And are those assumptions you made then are true now? Because I guess that's
yeah. Let me walk through that. So we started, the way the company started was we built 500 megawatts of Bitcoin data centers, and we were a data center operator for Bitcoin. We didn't mine ourselves. The original idea was for if anyone wanted to be a Bitcoin miner. So Eric, you want to be a Bitcoin miner? I'm gonna be the Equinix of Bitcoin mining. You show up. I help you get the equipment, or you have it yourself. We put it in. You get scaled out infrastructure, and Bitcoin hits your wallet, and you pay me dollars for your rent. And so that was where it started. What we ended up doing was Hyperscale model. So we moved over Hyperscale. We signed Marathon, and we grew really rapidly together. And we helped Marathon become the largest Bitcoin miner in the world. But that was our primary customer. And it was just at Hyperscale, and then they paid us. So it was the same model, but instead of retail, we went to Hyperscale. And then so about a year into that, we're still building it out aggressively. I thought about doing high performance computing as a nice add-on on our campuses. So, and you remember when you talked about HPC back in 22, we said, okay, we're going to do 5 to 15 megawatts of HPC. And that was a decent sized build for high performance computing, right? Pretty limited use cases for high performance computing. And so that we first did some retrofitting of one of our Bitcoin facilities to run GPUs. We said that doesn't work. We're not doing that. That's not a path we're going to go down. So then we hired some guys who were building data centers for Meta, and we designed this new, what I would call low cost, high performance computing, like purpose built, but less redundancy that you would have in a tier 3 data center. And we started building that. And then by December of 22, we had some GPUs running at our facility in North Dakota. And we had some customers, mostly universities, that were doing deep learning and machine learning on the GPUs. And then ChatGPT hits. Nothing really changed for us when ChatGPT hit, other than, that was cool. But then March of 23, NVIDIA H100 is introduced. And that's when the world started to change quite a bit for us. So we were out marketing the data center capacity, and we were running GPUs in it to show that it worked. And then we started getting introduced into some AI labs and some frontier model companies. And when I started talking to them, they were just looking for GPUs. They didn't want to deal with data centers. So we ended up buying GPUs and providing a GPU service to them. So we had about 1,024, so a full cluster of NVIDIA H100s running by July of that year. So we signed our first customer in May, had them running in July. That was pretty fast. If you remember, it was almost impossible to get H100s at that point, those first few months, even the first year, really. So we were doing the GPU service, and with everything I saw in the market, and then with my historical background, which was I was a tech investor for a long time, it popped into my head that I was thinking to myself, look, NVIDIA is going to fix wafer throughput at TSMC, right? I invested in semiconductors for a long time. And so they're going to fix wafer throughput at TSMC. They're going to fix the advanced CoWoS packaging for the semiconductors. They're going to fix transceiver manufacturing, these were all the bottlenecks that they kind of went through. I said they'll fix all of that much faster than we can supply the amount of data center capacity that's going to be needed, because I was looking around the market, and we were in the market with GPUs. So we had our capacity, but then we were looking at third-party capacity. There's really nothing out there for that kind of power density, right? 50 kW a rack is what we were looking for. That we were lucky that happens to be what we built in Jamestown. So 50 kW a rack, and then we're looking at the roadmap. And so I went back to my team and I said, guys, we need to go back to building hundreds of megawatts like we did at Bitcoin, but in high performance computing. And so we spent the time to figure out, we'd been through these few iterations, and then we spent time and we worked with actually NVIDIA's data center team, and we designed to the NVIDIA roadmap, and we designed a facility specifically actually for Blackwell. It wasn't called Blackwell at the time. Hadn't been named, hadn't been announced yet, but NVIDIA provides the roadmap and what's going to be the future. So we designed a facility around Blackwell. So we actually increased the footprint and increased the flexibility, but streamlined the way we build so that we can build faster and cheaper and just repeatable. But yeah, it's been a pretty big evolution. I'm glad that we what I call stubbed our toe at small scale, right? We were building much smaller when we went through a lot of these big experiences that we said, this doesn't work. I would have hated to figure out this doesn't work at a really big scale. But we should expect just continuous refinements to how we build. And I think this, it's AI it's dog years, right? Everything's changing so fast. So you're just trying to plan. If you're trying to plan for 5 to 10 years into the future, because we're building assets that we think are good for 30 to 50 years, you're trying to do everything you can to future proof.
Right. So in terms of one of those early buildings, you moved to like a 3-story design, right? Are you still at that 3-story design, or are you more horizontal now?
So now we've gone single story. Again, land is not a premium, but so this is one of the things that we learned. So on the first building, which is a really cool building, there's InfiniBand limitations on distance. And so we wanted to design a building that every GPU inside the building could be interconnected with InfiniBand, and you'd create one massive supercomputer. I think when it's, the building's turned over, all the equipment will be turned on in the next few weeks, and it'll be a massive, like probably the biggest supercomputer in the world, because you have 100 megawatts of critical IT load, all interconnected with InfiniBand. But the reason we did the 3 stories, you run network core through the middle, and then you can interconnect all of that on kind of that 30-meter distance limitation on InfiniBand. I think it went to 50 meters if you use single mode optics, but those are more expensive. So it was designed specifically for that. And then as we went through and learned more, okay, so now we can have 3 or maybe 4 data halls that are interconnected that way. We do 6 data halls in the flat format now. But you don't need a lot more than that. And the technology is evolving for Ethernet connectivity to go in between the InfiniBand. So it's just, this made more sense for the future. What we were doing at the time made a ton of sense, but this is what I talk about for future proofing. The building works just fine on Ethernet too. We were solving specifically for this InfiniBand limitation, and that's why it was built the way it was built.
But from an InfiniBand perspective, it sounds like you build these clusters and then you connect those clusters. I'm talking as a layman, but are you connecting these clusters together? Meaning you don't need to have this cube-like structure where you're shortening the fiber lengths to meet single mode or multi-mode limitations. Is that why? Because you're connecting up different clusters together.
So you can connect up different clusters, but if you want the InfiniBand altogether to create one cluster out of all of it, right? That's what that building is designed for. So you have 100 megawatts of critical IT load that is one cluster.
Right. But I think isn't that what most, I mean, you're ground zero for understanding, hyperscale requirements and stuff like that. But I would think that they want to build as big of a cluster as possible. And the cube type format seems to make sense. And so, I look at other hyperscale buildings, they build their own buildings and they're usually 1 or 2 stories. So they're not doing that cube thing. It sounds like you've gotten away from the cube. So it sounds like there's something else, I'm just trying to figure that piece out.
And as you go through what the technology is doing now, like from a networking perspective, you're going to, even if those are the flat building and they're further apart, the interconnect with Ethernet is going to work better to make those clusters operate. And then the software is getting more sophisticated so that clusters can work together on different work sets of the same model, right? Because so if you look at why do you want all of these connected together, it's specifically for training. So training versus inference. Now, if they're connected together like this, they work for training and for inference. If they're not connected together, they only work for inference. Generally, that's how it works. So ours is dual use for training and inference. But then now what we're seeing from our customers is that you actually chop these up and make the data halls themselves their individual cluster. So 25 megawatts of each one. And then they interconnect them with Ethernet, but you don't require, even inside of a cube building, they would still be doing the same thing. So you can do it in a flat format.
Gotcha. Okay. That makes sense. All right. Let's talk a little bit about GPU as a service. It sounds like you guys had GPUs as a service versus HPC cloud. So I see like 2 very successful companies. Yourself, Applied Digital, and Iron, right? It feels like you guys are going in different directions, but both seeing success. So for example, you guys had the GPU cloud and are kind of moving away from it sounds like. And Iron seems like they're going, running full bore towards that, adding more NVIDIA chips, that sort of thing, and offering it as a service. And so I guess any thoughts from that perspective?
Yeah. I think just my opinion is you decide on one or the other. We were data center first, and we added the GPU business, the cloud business, as when that's what we were at the early stage with those customers, and that's all they wanted, right? It was the cloud business. But then I looked at the market. I am saying, okay, well, what company do I want to create? And again, we're very focused on data center build, and we wanted to go directly after the investment grade hyperscalers, right? I looked at the private companies in the space, and I liked the business model, longer term contracts, guaranteed revenue versus the GPU business. And and lower risk, right? Lower technology risk from owning the GPU perspective. And so that was the business that I wanted to be in, was I'll call it the highly technical landlord business versus owning the GPU stack and providing cloud service. I didn't want to be a hyperscaler myself. And that's really the model you're choosing, those two different models. Can I be a hyperscaler, or do I want to service the hyperscalers? And one of the things that we saw as we went through negotiations with the hyperscalers on data center lease, some of them really didn't like us having that cloud business, even though it was very small. And so we said, look, we need to choose. Are we a data center company or are we a cloud company? And we were on the data center business. I like the risk profile of that business. Are the contracts we're signing, we've signed two, CoreWeave and then an investment grade hyperscaler. We have 16 billion of contracted revenue with that over 15 years. Both of them are 15 years. Both of them are effectively non-cancelable contracts. They can cancel, but they owe us the 15 years of payments, so 100% make whole.
Gotcha. Yeah, that makes sense. And I agree with you. It seems like you got to make one or another. You can't have your feet in both worlds, because you start to compete with your customers then,
Correct.
I suppose.
Correct.
Let's, in the rapid fire questions, you very firmly or quickly said grid power. Yep. You're like, I want grid power over self-gen, but you probably have looked at it. So what are your thoughts on on-site power? And there's a lot of chatter in the industry about demand flexibility. So this is a multi-part question, but what are your thoughts on on-site power?
So I did a behind the meter project already once, and that's it for me. That was enough fun. And so and what we see, our strategy in the future, and this announcement was actually made by the company we're doing business with, but we have some power gen stuff that we're working on, but it will all be on grid power gen. And there's some even much bigger things that we're working on, where you'll do on-site generation, but it will always be grid tied, and we'll work with the utility that's there to make sure that happens. And what we found in the kind of the behind the meter world was a lot more obstacles and roadblocks than we had anticipated. And it was largely because we weren't working within the system, right? There's a system, and these are, regional or local or even national. And there's been a system created for electricity in the United States, for the last 100+ years, right? And working inside the system seems to work a lot better than working outside the system. So it was just a fight on everything from on the behind the meter, just from an entitlement and getting things done and getting permitted and all of those things. And the site ended up being much later than we expected it to be because of those types of roadblocks that we had. And then if you look at those customers that I mentioned that we're going after, every single one of those customers would prefer grid power over a behind the meter or on-site gen solution, every single one. And so if that's what my customers prefer, that's what I'm going to go after. And so we have a lot of locations with grid power that, we went and found these a while ago, and we've been developing them. And so we have what I would call as really premium, properties with abundant grid power. And we're negotiating more of these. So we have 2 campuses under construction and signed. And I said publicly that we have 2 more that we're under negotiation on, and that continues to evolve to even more. So, what we're seeing is that our customers, we know they prefer grid. It's what they've been doing, for the past 15 years, and that's their preference, and they prefer to operate inside the system as well. But we did do a deal where there was a gigawatt of this one's interesting. We're kind of going backward in time on this. So as you probably know, if you want to do new gas power gen, if you want to get in line today for the 3 or 4 guys that make the turbines, you're going to get delivery in 2031 at the earliest, and probably 2032. So then you have solutions out there like Bloom, which, I think there's going to be a lot of that sold in the market. So that's a really interesting solution that they do on a fuel cell that uses nat gas as well. But what we did was we went back, and we've been working with a company that's a 160-year-old company that's deployed 400 gigawatts of power generation worldwide. There was a big player in the coal industry, but they've done a lot of retrofits from coal on steam boilers to nat gas. They've never done new build, but they've done new build on coal, and then they've retrofitted them to nat gas. So now we're just going to do new build of nat gas steam turbines, and we can start getting delivery in late 27 and 28. But those will be on-grid assets that then can feed our facilities. So it will still stay within the system. But the thing I like about that is, it's we know what the useful life is, we know what the cost is, we know what the efficiency is. Like these have been done for over 100 years, and they last forever. And so it's a great asset for us to build and know exactly what we're getting instead of something new.
Got it. Yeah. Is this something that you'll be operating, or is that partner that will be operating?
We won't be in the power business ourselves. Applied Digital will not, but so we're working with partners on that. But we wanted to go procure the supply chain. I thought that it was a pretty novel idea of doing this. We've been working on it for a little while, and but I was already in discussions with our utility partners on this. And even if it wasn't the utility itself that built it, right, it'll go onto their system, and you could bring an IPP or some kind of IPP into it that would do it as well.
So it's almost like you're making your own co-location, or you guys are jointly choosing. You're probably choosing the site, or jointly choosing the site together and co-locating together.
Yeah, for sure on the power gen, and then like the way we choose our sites, a lot of the power is there, but the electrical infrastructure to go to much bigger is already there. But at some point, if you're going to do in the same state, if we want to do 3, 4, 5 of these, we need new power gen for sure. There's going to be new power gen all over the country, so we need new power gen, but it'll go inside of the system. But the you don't have to co-locate it on the site. You just need to get it on in an area of the system that can deliver. Like there's already robust delivery there, so you can deliver it to the site.
Mm-hmm. Makes sense. So, I mean, you brought up a site selection a little bit, or at least you allude to it. So let's talk about site selection. What do you look for in a new site? Obviously, if there's available grid, that sort of thing. It sounds like, maybe a second question there is, will you be expanding outside the Dakotas? You probably can't talk about specific locations, but just generally,
So on the second question, the answer is I expect to, yes. One that would be nice is to expand to a southern state, so that we can do dirt work in the winter. Right now, we're in a place where, we're hitting the time of year where kind of any dirt work is done for the year. It's been good weather there this year so far, so we've been able to continue. But it would be nice to move into a state where you can do year-round construction. In North Dakota, we do year-round construction, but you can't do dirt and foundation work once it freezes. You're kind of out of that until the late March or April timeframe. So you should expect us to move to do it, expand into a different state, and then we just want to diversify geographically as well. It just makes sense for our business. And then on the first question, when we do site selection on, we're looking for power and we're looking for fiber. Then those are the two, and then obviously the available land.
Where do you find the information on substation uptime?
We had to do it with the utility.
Okay.
Yeah.
So they can almost self-report in a way what the uptime was.
I don't know if they self-report publicly, but they did the study for us historically to tell us what it was.
Okay. Yeah. Interesting. Okay. Makes sense. So the DOE, Christopher Wright, the Secretary of Energy, talked about a rule change for load flexibility, right?
Yep.
Get connected quicker. If you're flexible, you get, through the queue in 60 days or so. We'll see how that shakes out. But what are your thoughts on that? Because it seems like it'll change the game from a data center site selection perspective in a pretty big way.
Yeah, but it still depends. So flexible load, right? We need our end customer to be okay with that. And historically, they have not been. They're extremely rigid, or historically have been extremely rigid. Things are changing depending on demand levels all the time. But you can create a non-flexible, a fully redundant data center while using flexible load, but you need to install, more backup on site, whether that's battery energy storage systems, or I mean, we have backup gen, but you really don't want to, you want to run that as little as possible. So if it's a flexible up down a lot, then you definitely need to do battery, and you may need to do that a lot anyways, just for load balancing perspective on site with these really large sites. But it's something that we're into a lot, as far as, will our customers accept that? How do we make it so that it looks like firm power to them, even if it's flexible load, because it's a good rule change, and potentially a really helpful one for the industry.
So maybe in other words, look at battery stocks to invest in.
Well, how about this? If you find a good one, let me know. I mean, we've been digging through a lot. The issue you have with battery, there's a lot of good companies out there doing it, is so with data center, with these large GPU loads, the power usage fluctuates, and it fluctuates fast. And it would be nice to balance that with batteries. Generally, what you see is they can discharge at the rate you need to, but they can't absorb power or charge at the rate you need them to, right? That's the mismatch. And so how did you balance that? I mean, we've been working a lot on that, like, supercapacitors, something of that nature. So there's a lot of work going on there. But if you find something really interesting, or one of your listeners has something really interesting, please get in touch with me on that, because it's one of the problems that or one of the solutions we're looking for.
Got it. So solving the discharge and charge imbalance.
Or if there's another non-battery technology that's not just load banks, right, to manage the power fluctuation.
Right. Okay. Makes sense. And so from a kind of a Rocky Mountain or Midwest, upper Midwest, the Dakotas, I think, Colorado for sure does not have sales tax exemptions, right? There's only like 10
Colorado
states.
Does not. North Dakota does.
North Dakota does. South Dakota doesn't. Do you know anything about, like, in terms of how we as an industry can kind of push any that listeners or myself can get involved and help to kind of unlock that piece? Because I think it's a big unlock once to get that.
We're working a lot in South Dakota and trying to help them understand the big benefits of data center, that you still get a huge benefit even without if you give the sales tax exemption, right? This is just on the IT equipment internal to the data center. And it's 40 or 41 states have the exemption. So if you're one of the states that does not, because it's a big disadvantage. And we have a location in South Dakota that we could have been building already had that exemption been in place. But it's a hang up for our customers, right? It's not an expense that we pay.
Right. I couldn't agree more from that perspective. I live in Colorado, so it's kind of close to my heart here. Kind of getting more data centers into the state. All right. So kind of moving to the last couple sections of our podcast here. We call it the data center war story. It's effectively a time in your career that might be definitive or a dramatic, something dramatic that happened.
So this was prior to running these AI factories, the HPC factories. We were running our Bitcoin facilities, and we had transformers that started to fail. They were faulty, and these were Chinese source transformers. When you build Bitcoin, it's built for cost. That's truly what it's built for, is for cost. And they started failing. And we dig into it, because generally you get one that fails first, and then we started digging into it. It was a flaw. It took in these things. It takes a while to kind of figure out what's going. You're trying to do the post-mortem. So you hope it's just an easy fix and a component, and so you end up going weeks on this to try to figure it out. And we figured out eventually that it was a fatal flaw for these transformers, and it was through the entire site. Right, this is 180 megawatts of capacity. The good news is Bitcoin. Your contracting is a lot more flexible, because in the Bitcoin world, 95% uptime is really, really, really good. So it's just different. It's a totally different animal. But like, our team mobilized. This is in a market where it was difficult to find transformers, but we found a lot of the 2.5 megawatt transformers that we needed. We replaced them in a few months time frame. We had our customer back up, and our customer was patient with us to get that done. But I was really proud of how quickly the team swapped that out, because it's a massive task to get that done. And it was definitely a scary time. It was our largest campus at the time that had the issue, and it was extraordinarily frustrating. But the team just fought through it and got it done and back online. But it was a serious test for everyone.
I bet. Yeah. And certainly, yeah, Bitcoin's very different than HPC. Their expectations, they can be down. It's every 10 minutes you're minting a new Bitcoin, or there's a new block that's written, and so yeah, you can be offline. And anyways, let's move on to the next section. The top picks. So this is something that you want to share that's useful to your life. If you have something in mind, or I could go with one, and while you kind of think.
Go ahead. I'm curious to hear yours.
All right. So I got married this summer. Second marriage. It's always the sequel's always better, I guess.
Yeah.
In this case, so,
we always hope. We hope for sure.
That's not my top pick, though. That getting married isn't my top pick, although it probably should be. It is. I have never gotten a custom suit before. I don't wear suits very often, and I got a custom suit for the wedding, in part because I wanted a 3-piece suit, to stand out a little bit more, rather than a tuxedo and that sort of thing. And so there's not too many, when you go to the stores, there's not too many 3-piece suits. So I had one. Someone said you should have it made, and I did. And the tailor came over and he looked at my wife's paintings my fiance's at the time, paintings on the wall. He's like, this would be great for inside the suit. And so so that's what we did. We put one of her paintings inside the lining jacket. He had it printed, and then so the lining of the jacket had her painting in there. So I thought that was pretty awesome.
That's really cool. That will be. I mean, I like it because it's obviously a keepsake, but it's something you can use all the time too. That has that keepsake inside permanently. That's great. Mine, I was thinking different along the lines or along a different line. I was just like, what do I do? So we've grown and ran this business. Something that people don't really know about me is I have a lot of kids and big family, and over a big age range too. But between work and doing a lot of kid stuff consumes most of my time. The big change I've made over the past 5 years, which has just been a really big change for me, is this is super boring. I just get up early. I get up early every morning. I get up earlier than everyone else gets up. And it's truly the only time I get to myself during the day. So that I had to go find that time somewhere, and that turned out early. But something I highly recommend for everyone. This is so even if I'm traveling, whether it's vacation or work, I find myself, and I find my days to be a lot better when I have early mornings versus late nights. And my biggest one is, I always tell people, you travel anywhere, get up for the sunrise. Don't worry about the sunset. Everyone sees the sunset. But you get up at sunrise, especially you go into Europe or a lot of other places in the world. You own that location at sunrise. No one else is around. There's almost no one around, especially in the summertime. But that's been a big booster in life for me, is to get that extra time just to myself, collect my thoughts.
I like that. Yeah, I'm turning into an early morning person as well. Almost by accident. And there's a lot of research now, Huberman Lab and others are talking about how you get this early morning light, that sunlight right in the sunrise, and it's good for you to help set that circadian rhythm. Yeah, makes sense. Awesome.
The suit's a lot cooler though.
Maybe I had more time to think about it. But yeah, so but yeah, it was great to have you on. I appreciate getting to know you a little more and learning about the business and that sort of thing. Where can we find more about you and the business?
Our website, applieddigital.com. We post a lot on our socials. We try to be as absolutely as transparent as possible. You get monthly updates on our builds, construction, a lot of video footage, all of those things.
Awesome. Well, I appreciate it. Thanks for coming on.
Yeah, thanks for having me, Eric. I appreciate it.